Namaste and welcome back to JEE Chemistry with Typical Mug. This is class 32, Organic Chemistry, part 7, the carbonyl compounds. One group rules 3 whole families. The carbonyl, a carbon double bonded to oxygen. In an aldehyde or a ketone, it stands exposed. It's carbon electron hungry and it's oxygen greedy. So nucleophiles rush in to add across the double bond. Attach a hydroxyl and you have a carboxylic acid whose proton slips away with unusual ease, because the carboxylate that remains spreads its charge over 2 oxygens. Learn the nucleophilic addition, the tests that tell an aldehyde from a ketone, and why an acid out-acids a phenol. And a vast tract of organic chemistry is yours. Today, the carbonyl compounds. One idea at a time. Here is what you will master today. First, the carbonyl group and nucleophilic addition. Second, the preparation of aldehydes and ketones. Third, the reactions and named reactions. Fourth, the distinguishing tests. And fifth, carboxylic acids and their acidity, one idea at a time. Let us set the foundation. The carbonyl, a carbon double bonded to oxygen, found in aldehydes, ketones, and acids. Polarity. The carbon-oxygen double bond is polar. The carbon is electrophilic, the oxygen electron-rich. Nucleophilic addition. This is the defining reaction of aldehydes and ketones. Master line. The carbon invites the nucleophile. Now look at the picture. Nucleophilic addition to a carbonyl. The carbonyl group. A carbon double bonded to oxygen. The carbon carries a partial positive charge, the oxygen a partial negative. Nucleophilic addition. A nucleophile attacks that electrophilic carbon. The intermediate, the pi bond breaks, and the oxygen takes the negative charge, giving a tetrahedral product. Aldehydes versus ketones. Aldehydes are more reactive. They have less steric and less electronic hindrance. Now, how the carbonyls are made. Aldehydes, from primary alcohols by oxidation, and from acyl chlorides by the Rosenmund reduction. Ketones, from secondary alcohols by oxidation and from acyl chlorides with a Grignard reagent. Both, from alkynes by hydration and from the ozonolysis of alkenes. Aromatic, Friedel, Crafts, acylation give the aryl ketones. Now the reactions, the heart of the chapter. Nucleophilic addition. With hydrogen cyanide, it gives a cyanohydrin. With sodium bisulfite, a solid adduct. With a Grignard, it gives an alcohol after hydrolysis. Reduction to an alcohol or fully to an alkane by the Clemenson or the Wolff-Kishner reduction. Aldol condensation. 2 carbonyls with alpha hydrogens under a base give a beta hydroxycarbonyl. Cannizzaro. Aldehydes with no alpha hydrogen disproportionate under a strong base. Now look at the picture. Why carboxylic acids are acidic. The acid, a carboxylic acid, loses its proton to form a carboxylate ion. And resonance. The negative charge is delocalized equally over both oxygen atoms. The stability. This stabilizes the carboxylate, so the acid loses its proton readily. The order. Carboxylic acid is more acidic than phenol, than water, and than an alcohol. Now the carboxylic acids themselves. Acidity. They are more acidic than phenol because the carboxylate is resonance stabilized. Substituents. Electron withdrawing groups increase the acidity further. Esterification. With an alcohol they form an ester plus water catalyzed by acid. With reagents. Bases give salts and phosphorus pentachloride or thionyl chloride given acyl chloride. The half-Z reaction, alpha halogenation, using a halogen and red phosphorus. Now, the tests that tell them apart. Toluenes, aldehydes give a silver mirror, ketones do not. Feeling, aliphatic aldehydes give a red precipitate, ketones, and aromatic aldehydes do not. Iodoform, methyl ketones and ethanol give a yellow iodoform precipitate. Now match each reaction to its outcome. A carbonyl plus a nucleophile goes to nucleophilic addition. An aldehyde plus toluenes goes to a silver mirror. two carbonyls plus a base goes to an aldol condensation. And carboxylic acid acidity goes to carboxylate resonance. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. Aldehydes are more reactive than ketones. Correct. Statement 2. Ketones give a positive tolerance test. Wrong. Only aldehydes do. Statement 3. Carboxylic acids are more acidic than phenols. Correct. So the answer, 2 are correct. Statements 1 and 3. The trap is the tolerance test in statement 2. Now, the 2 mistakes that quietly cost marks. The truth, aldehydes give the tolerance and feeling tests. Ketones do not. The trap, expecting a ketone to give a silver mirror. The second truth, carboxylic acids are more acidic than phenols because of carboxylate resonance. The second trap, confusing the aldol reaction, which needs an alpha hydrogen, with the Cannizzaro reaction, which needs none. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. The reactive site of a carbonyl? The electrophilic carbon. Question 2. Which is more reactive? An aldehyde or a ketone? The aldehyde. Question 3. The silver mirror test. Tolerance? Question 4. An aldehyde with no alpha hydrogen under a strong base? Cannizzaro. And question 5. Which is more acidic, a carboxylic acid or a phenol? The carboxylic acid. Let us gather it all in one breath. The carbonyl, carbon-oxygen double bond, is polar, and nucleophiles add to the carbon. Aldehydes are more reactive than ketones. The aldol reaction needs an alpha hydrogen. The Cannizzaro reaction needs none. Tolls and feeling identify the aldehydes. Carboxylic acids are acidic because of carboxylate resonance. Next class, the amines and the diazonium salt. One group, endless chemistry. Everything in this chapter radiates from a single polar bond, the carbonyl. Its electron-poor carbon draws nucleophiles in, giving cyanohydrins, alcohols, and the glade aldol and Cannizzaro reactions, a silver mirror or a red precipitate. Then betrays an aldehyde in an instant. Cap that carbonyl with a hydroxyl, and you have a carboxylic acid made strong by the resonance that steadies its anion. Learn the addition, the tests, and the acidity, and 3 families fall into one clear pattern. Next class, the nitrogen chemistry of the amines. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.